Hi, Charan. Good morning.
Hi, sir.
So, how are you?
Fine, sir.
Right. Okay, Lokesh. Good morning. Let's start now. Chili. Now let's continue with the previous thing what we were discussing, and current electricity we were discussing. And in the current electricity, we discussed about the how the current depends on the microscopic property. Okay, combination of resistor, right? Series and parallel combination we discussed. Then balanced V-test-one bridge we discussed, and the last thing we discussed was the meter bridge experiment. Okay, the meter bridge experiment works on what? The condition of the balanced Wheatstone bridge. It works. Okay, clear? Now let's continue the next part. Okay, so up to this we have discussed, right? Actually. So right now these things we have discussed. Yesterday we were just discussing some of the questions. So now after meter bridge, let's discuss about the series and parallel combination of resistor. Okay, so in series what happens? In series combination of resistance, what happened? R equivalent, we get it as the R1 plus R2 plus R3. And in parallel combination, what we got it? 1 by R equivalent as 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So that is called the series and parallel combination of the resistor. Okay. Now, the next thing is what? Next thing we have the series and parallel combination of the cell also. Okay. Cell means what? The battery series and parallel combination. Okay, so let's discuss that one. After that, we will discuss about the Kirchhoff's law, the combination of cells. Okay, now there will be two combination of the cell. One will be what? The series combination, and the second one will be what? The parallel combination. What does it mean by series combination? If current remains same through all the cells, we will call it series combination. And parallel means what? If potential difference is same across all the cell, then what we will call? We'll call the parallel combination. And cell means what? Cell means a source of EMF. This is the representation of the cell, isn't it? This is what? This is the representation of the cell. So what will happen? Every cell will have EMF. This E is representing what? EMF of the cell, and a small r is representing what? The internal resistance of the cell. Means every cell will have what? Some internal resistance as well. Okay? Clear? Every cell has what? EMF and internal resistance. Now, let's discuss about the first thing called the series combination. In series combination, what happens? Let's say this is the first cell, E1, internal resistance R1. This is the second cell, E2, R2. Third cell, E3, R3. Like that, there are many cells are there, and that is overall connected with what? Connected with an external resistance. What? External resistance R. What are these cells? E1 internal resistance R1, E2 internal resistance R2, E3 R3. So here, what is the E equivalent will come? Means if I want to replace these many cells by a single cell, if I want to replace these cells with a single cell, what we should do it? So we should replace it by the E equivalent. Up here, in the series and parallel combination of the cell, two formula will come. Okay, series two formula will come, parallel two formula will come. Okay, not like resistor. Resistor series, what is the value? R1 plus R2 plus R3 like that. But here series, what is the equivalent EMF will come? See, first of all, see how is the polarity? How is the polarity of the cell? You see, positive, negative, again positive, negative, isn't it? So you see, one cell positive negative is connected to other cell positive negative, then other cell positive negative. Do you see that same pattern is repeated or not? Means first cell positive and negative terminal is connected to second cell positive connection, positive terminal, right? So when these kind of arrangement is there, then equivalent EMF will be what? E1 plus E2 plus E3 plus E4 like that. Meaning is what? That if all these cells are supporting the current in the circuit, then equivalent EMF will be the sum of EMF of each cell. And what will be equivalent internal resistance? The equivalent internal resistance will come R1 plus R2 plus R3 plus R4 like that. R1 plus R2 plus R3 plus R4 like that. That means what? This much circuit you can replace it by a single cell. E1, E2, E3 you can replace it by what? A single cell of what EMF? Equivalent EMF. What internal resistance? Equivalent internal resistance. And now you can connect it with what? An external resistance. Understand? So if polarity is connected in such a way that positive, negative, alternate positive, negative are connected, in that situation, what happened? Equivalent EMF is E1 plus E2 plus E3 like that. Understood? But if one positive connected to other positive, right? Or one negative terminal is connected to other cell also negative terminal. In that case, we should write it E1 minus E2 plus E3 depending on how they are connected. Understood? So we'll take an example and try to understand when we should add them, when we should subtract them. So please tell me, series combination, is it clear? And you see that if the same current is flowing through all the cell, na? That's why they are connected in what? The series. Understood? Please tell me, clear this one? The first one is called the series combination. The second one is called as what? The parallel combination of the cell. So in parallel combination, what happened? Let's say this is the first cell, E1 EMF, R1 internal resistance. There is another cell, E2 EMF and R2 internal resistance. Third cell, E3 EMF and R3 internal resistance. Like that, many are there. And finally, that is connected with what? An external resistance R. Here again, if you see that polarity, positive, negative, positive, negative, positive, negative, see that all positive on the same side. Na? So here, equivalent EMF, how much it will come? So you can replace it by what? Replace it by a single battery or single cell of what equivalent EMF? E equivalent and R equivalent, and then you can connect that with what? With the external resistance R. So what is the equivalent EMF? In this case, it will come E1 by R1 plus E2 by R2 plus E3 by R3 divided by 1 by R1 plus 1 by R2 plus 1 by R3 like that. And what is the R equivalent in parallel? So 1 by R equivalent will come 1 by R1 plus 1 by R2 plus 1 by R3 like that. understand the series and parallel combination of the cell, but we must look at the polarity to understand that will it be just the sum or will it be addition and subtraction, both will be involved. So we'll take some example and try to understand that is it going to be the total sum or the sum and difference. We have to take both of them when we are going to solve the question. Please tell me, is this part clear? Please tell me, clear this one up to what we have discussed till now?
Yes, sir. Clear.
Right. Now, the next thing we will discuss is that the two Kirchhoff's law, which is useful for solving any type of circuit problem. Okay. Any circuit problem is there. We have what? The two law called as what? Kirchhoff's law. Okay. What is the Kirchhoff's law? There are two Kirchhoff's law. One is called what? Kirchhoff's junction law, or it is also called as Kirchhoff's current law. Okay. And the second one is called Kirchhoff's voltage law. Okay. First one is called as the Kirchhoff's current law, or it is called as the Kirchhoff's junction law. Second one is called as the Kirchhoff's voltage law or Kirchhoff's loop law. Okay. So let's try to understand and how we are going to apply these two laws. Okay. The first one we are going to discuss is called Kirchhoff's current law. Short form it is written as KCL, current law, or it is also called as Kirchhoff's junction law. Okay, Kirchhoff's current law, or it is also called as what? The Kirchhoff's junction law. Okay, what does it mean? Kirchhoff's current law or Kirchhoff's junction law is only applicable for what? At the junctions, right? At where? At the junction. Okay, and whenever we say junction, junction means what? Where at least three branches are there. है ना? What will be called a junction? A junction means what? At least at a point, if three branches are there in a circuit, there are three branch at a point, then that point will be called as what? A junction in the circuit. Understood? So, what is the Kirchhoff's current law or Kirchhoff's junction law? Let's say in the diagram, it is given like this. This is the branch 1, this is the branch 2, this is the branch 3. Can I call this is the junction? This is what? The junction. Let's say in this branch current how much it is coming? I1. And other two branches what is the current? I2. And this branch has what current? Something I3. Okay. Please understand the direction. Direction is very important here. Whenever we are applying the Kirchhoff's junction law or current law, this direction of current in the branches are very much important. So what is the thing we are going to write in the Kirchhoff's current law or junction law? See that Kirchhoff's current law or junction law is written in the two way. Okay, what are the two way? Sometimes they will write at any junction. Okay, what is the Kirchhoff's junction law or Kirchhoff's current law? According to this, at any junction, what should happen? Can you write it? Incoming current should be equal to what? The outgoing current. Means whatever the current enters at a junction, the exactly same amount of current must be leaving the junction, isn't it? At any junction, right? At any junction in a circuit. Okay? At any junction in a circuit, what should happen? The amount of current entering the junction must be equal to what? The amount of current exiting the junction, isn't it? So if you look at here, what you will see? Tell me, what is the incoming current? Is the I1 is the incoming current? And what is the outgoing current? I2 and I3. है ना? I2 and I3 are the outgoing current. So I1 must be equal to what? I1 must be equal to what? I2 plus I3. So this is the one form of Kirchhoff's current law. There is another form also where the Kirchhoff's current law is written. Okay, what is that? Both are same thing. Okay, these two are just two different format only. Okay, na? These two are just two different format. So what is the Kirchhoff's current law? Or junction law says that at any junction, the summation of current is equal to 0. Ab- are these two different laws? No, it is the same law, but these two things are written in two different formats. Understood? What is then? They are written in what? They are written in two different formats. So summation of current means what? Are you thinking, sir, I1 plus I2 plus I3 equal to 0? Yes, but with proper sign. With what? With proper sign, I should write it. Okay. So with proper sign means what? That here, in case of current, how do we assign the sign to a current? Matlab, which current will be positive or which current is going to be negative? Any idea? Tell me. In case of current, how do we decide about the sign? So in case of current, if we want to understand about the sign, it is about at a junction, which current is incoming current, which current is outgoing current. The sign of positive and negative sign of current at a junction is decided by whether the current is what? Incoming or outgoing. If I consider incoming current positive, outgoing current will become negative. Understood? So please tell me here, incoming current is what? How much is incoming current? I1. So I will write it plus I1 plus. What is the outgoing current? Outgoing current is I2 and I3. So I will write it minus I2. I will write it minus I3. Understand? I am just adding. है ना? I am just adding the current, but with the sign. What I am doing? I am adding the current, but with what? Sign. And how do we assign the sign to the current? So at any junction, if a current is incoming and if incoming current is taken as positive, what will happen? Outgoing current should be taken as what? Negative. Okay. So when you are adding a current, what you should do? Incoming current have you have taken positive, outgoing current negative, right? Just add them with their sign, and that summation should be 0. Check it. Am I getting I1 equal to I2 plus I3? Check it. So isn't it both the thing, this first one and the second one is exactly same thing written? Check it. The first and the second one both are what? Exactly same thing done, but the difference is what? The difference is how they have been reached to the point. How we reach that point. In the first case, what did we apply? Incoming current equal to outgoing current. We got I1 equal to I2 plus I3. And the second time, same Kirchhoff's junction law I am applying, but is this time when I am applying the Kirchhoff's junction law, I am writing in the form of what? The summation of current form we are writing. Understood? So both are same thing only. Do you understand? Please tell me.
Yes, sir.
So that is called the Kirchhoff's current law or Kirchhoff's junction law. That is the first Kirchhoff's law. there are two Kirchhoff's law. Okay, the first one is what? Kirchhoff's current law or Kirchhoff's junction law. The second Kirchhoff's law, what we have, is called Kirchhoff's loop law. Okay, the second one is called Kirchhoff's loop law, or it is also called as the Kirchhoff's voltage law. Okay, it is also called as what? Kirchhoff's voltage law, KVL. Short form, we write it as the Kirchhoff's voltage law or Kirchhoff's loop law. Okay, what does it mean by Kirchhoff's loop law or Kirchhoff's voltage law? Let's say there is a simple resistor R given to us in the question. There is a battery and there is an internal resistance of the battery. This is E and this is a small r. Now, if you connect this circuit, what will happen? Current will flow in this circuit, isn't it? And battery will supply the current. How it will supply the current? It will supply the current in this direction, isn't it? How do I know the direction of current? By looking at the positive terminal of the battery. Battery will give the current in which direction? From the positive terminal of the battery, the current will be what? Coming out. Okay. Now, what is the Kirchhoff's voltage law or Kirchhoff's loop law? So, according to this Kirchhoff's loop law or Kirchhoff's voltage law, in any loop, in any loop, loop means what? Loop means the starting and ending point is same, right or not? Whenever we call something a loop, loop means what? If starting and ending point is same, then that thing will be called as a loop. So, in a loop, what happens? Let's say we are starting at some point in the loop. Okay, let's say we are starting at some point in the loop. Let's call this point as the A. And in the loop, you can go any direction. You can go clockwise, you can go what? Anti-clockwise. So let's say you went from A to B, a resistor came in between, then you went from B to C, another resistance came, and then you again come back to the same point A, right? So, as per the Kirchhoff's voltage law, what happens? Summation of voltage drop. Okay, what is the Kirchhoff's voltage law for a loop? Understood? For a given loop, what should happen? Summation of voltage drop should be equal to what? Zero. Summation of voltage drop should be equal to what? Zero means if you move in a loop, move in a loop means what? In a circuit, in a closed circuit, if you start from a point and you again reach to the same point, right? Then that means the loop is completed. So in the path, whatever the potential difference come, if I add all those potential difference, what will happen? The summation of potential difference will become how much? It will become zero. Understood? What is the summation of potential drop will become? Zero. Like here, if let's say I want to use the same concept in this loop, let's say for what? For which loop I am talking? I'm going from A to B, B to C, and C to A. Is it a loop? Check it. A, B, C, A. Is it the loop? Now tell me, when you are going from A to B, think about it and tell me, when I am going from A to B, what will happen? Am I going from high to low potential or low to high potential? Please tell me, how do you decide about it? Low and high potential in a circuit, how do we decide? How do we decide there is a point in the circuit which is high potential or low potential? So if we go in the direction of current, na, see, always look at what is you are crossing. Are you crossing a resistor? Are you crossing a capacitor? Are you crossing an inductor? Or are you crossing a battery? Okay. So if it is a resistor, which you are crossing, then what happened? In a resistor, current always flow from which to which potential? In a resistor, current always flows from high to low potential. And if I look at the direction of current, है ना? If I look at the direction of current, I find the direction of current is from A to B. That means A must be high potential and B must be low potential. So if I go from high to low potential, I will write minus. Minus. How much minus? Current is I, resistance is R. So minus IR. Now, when I go from B to C, can I see that B to C is again the direction of current? The direction of current, that means minus. How much minus? I into R. Now C to A. C to A, there is a battery in between, isn't it? When you are going from C to A, then what we have? There is a battery in between. So how do we decide high and low potential in case of battery? So in case of battery, we should see the polarity of the battery. C is connected to negative terminal of the battery. है ना? See that? This is negative terminal, this is positive terminal. So C is connected to negative terminal, B is connected to A is connected to positive terminal. That means what? C is low potential and A is high potential. So C to A becomes low to high potential. The low to high potential means plus. How much plus? Battery EMF. Now I have completed my loop. I reach the point A. The summation of potential difference should be what? It should be equal to 0. If we simplify it, what are we getting? E equal to I common small r plus capital R we are having. So what is the current in the circuit we are getting? E divided by small r plus capital R. So you see that you could have directly answered that also, right? By finding, okay, R equivalent of this circuit is R plus a small r. And then you can find out what is going to be the current. Or for a single circuit, a simple circuit, Kirchhoff's loop law is not much important. But when it becomes a uh, multiple branches circuit, है ना, multiple loop circuit, then we will need the Kirchhoff's loop law or Kirchhoff's voltage law to solve the questions. Okay. Now let's practice some of the questions. Many things we have discussed till now, like series and parallel combination of the resistors we have discussed, right? We have not yet discussed any question on that. So now let's practice some questions on what we have learned till now theoretically. Okay. चलिए, let's practice some questions now. Okay. चलिए, let's see. The question gave something like this. Okay. And this is given to us as the 4 ohm. This is given 4 ohm. This is given 8 ohm. And this is again given as 4 ohm. Okay. And this battery is given as 32 volt. Okay. Now they are asking in the question, find current in each branch. Okay. First thing, find it. What is the current through battery? Find current through battery. Okay. Current through battery or current through the cell. How much is that? And second thing, find current in each branch. Let's find the current in each branch. Okay, so see, whenever you want to calculate current through battery, na, a simple method is what? If a multiple resistors are given in the question, find out the R equivalent. About what R equivalent we will find out? About the ends of the battery. Matlab 4 ohm, 8, 4, these many resistors are there na. Let's find the R equivalent of this battery across which end? Across this end where the battery is connected. Okay, and once you get R equivalent, after that you can use it the current equal to V by R equivalent one. Okay, please tell me how much is that coming, and try to get the answer. Please tell me. Find this one. Find the current through battery, how much is that coming, and what is the current in each branch, how much is that coming. Please tell me how much is this coming. Coming or not? Please tell me. See, can I say this 4 ohm resistance and this 4 ohm resistance, are they connected in series to each other? Why series, I will say? Because whatever current will flow through this 4 ohm, exactly same current will flow through the another 4 ohm, isn't it? So you can say these two are connected in what? These two are connected in series. So if you simplify this circuit, this is 32 volt, this is 4 ohm, this is 8 ohm. Okay, this is 8 ohm given to us, this is 4 ohm given, and this 4 and 4 are connected in series. So I can replace it like what? 4 and 4 in series. The 4 plus 4 will come in 8 ohm. Now you look at this 8 ohm and look at this 8 ohm. Are they connected in parallel? How do I know that? Look at these 2 points and these 2 points. Can I say both 8 ohm are connected across the same potential difference? Please check it. Both 8 ohm are connected across what? Connected across the same potential difference. So if two resistors are connected across same potential difference, we will call them these connection as what? We will call these connection as the parallel connection. So 8 ohm and 8 ohm in parallel. So how much it will come? 4 will come. 8 ohm and 8 ohm in parallel. And 1 by R equivalent, 1 by R1 plus 1 by R2. So now this circuit will be further converted into like this. 32 volt, 4 ohm, and this is another 8 ohm and 8 ohm in parallel, gives me 4 ohm. Now you check it finally. Is this your finally circuit? What is the final circuit now we have? So can I say my final circuit is 32 volt battery and this 4 ohm and 4 ohm connected in series, right? Check it again. These two become what connection? These two become the series connection, है ना? The 4 and 4 in series, that will come 8 ohm. Now I can get the current. What will be current? So now this has total EMF of the circuit is 32 and total resistance of the circuit is 8 ohm. So what will be the current in the circuit now? 32 divided by 8, that means 4 ampere. That means from here what current will flow? 4 ampere will flow. Right or not? Now let's go backward to calculate what is the current flowing in each branch. Understood? So tell me, here what is the current flowing? 4 ampere. Same diagram, if I think about here, can I say here the current is 4 ampere? Okay. Let's go backward further. Can you tell me what is the current flowing here? 4 ampere, right? Now tell me, is the 4 ampere current will reach here? Is it a junction here? Please tell me. Please tell me, is this a junction? How much current is reaching the junction? 4 ampere. And is that current is going to distribute in the two branches, this branch and this branch? Please tell me. And can you tell me how these two branches are connected? Are these two branches are connected in parallel? So parallel, in parallel connection, can I say that delta V equal to IR? Please tell me. Delta V will be equal to what? I into R in parallel. Please tell me, in the parallel combination, what happened? Delta V potential difference equal to what? I into R. And you see, in parallel, delta V is same. That means, can I say I will be inversely proportional to R, right? So here 4 ampere will come. Should I distribute in their inverse ratio of resistance? And as these two resistance are equal, so can I say equal current will be distributed in these two branches? So that means what? Can I say finally here in the circuit current came 4 ampere? It reached here 4 ampere. That 4 ampere current got distributed 2 ampere, 2 ampere, right? This is the 2 ampere we have calculated now. And what is the current here flowing? 2 ampere. You could have solved it using the Kirchhoff's loop law also. Here you see 2 ampere coming. Here how much it is coming? 2 ampere coming. How much current it becomes here? 4 ampere it becomes, right? So you could have used the Kirchhoff's loop law also to solve this question. Or what? Or a simple series and parallel method also. Okay. So you should know both the method to solve the question. Is that clear? Please tell me. So let's discuss the next example now. Okay. In this example, what is given to us? Okay. This is given as 10 volt and this is given 2 ohm. And this is given as 20 volt. This is again 2 ohm. These two are the resistance given to us, 10 ohm and 20 ohm. Again, the same question is there. Find current in each branches. Okay. I can ask you only first battery, you tell me, second battery, you tell me. But let's find out. Find current in each branches so that you will be able to understand how we are going to apply the loop law or how do we apply the series and parallel method. Okay. So please tell me what is coming current in each branch. Solve it using the series and parallel method of cell and resistance. That is the one method. Second method is what? Using the loop law also you can solve it. So which method you feel is easier, which method you feel it is having less calculation, use that one to solve this question. Okay. Can you apply series and parallel combination of cell here? Check it. Please use any one of them, series and parallel combination of cell, right, to get the answer, or the loop law and the junction law to get the answer. Whichever you feel is more convenient, apply it. But learn both the methods. But always learn both the method to solve the question, series and parallel method, as well as the uh, loop law method. Okay. So please tell me which one you are applying. Which method you are applying? Tell me. Which method you are applying? Not solving? Chalo, let me
Solving, sir.
explain. Okay, okay. Just try it, any one of them, and see that what is the answer coming.
Sir, will there be separate current for that line, sir? 10 ohms and 20 ohms.
No, no, no. Both will have same current. No? They are connected in series.
So should we add in series and we should.
Yeah, you can replace it by a single one. 10 and 20 ohm, you can replace it by a single resistor of 30 ohm because they are connected in series. Tell me, coming this one? Okay, let me discuss with you by the two methods. The two method is what? The series and parallel method, and another one is the uh, loop law and junction method. Okay. So if I'm applying the series and parallel method, you will find an interesting thing that there are two cells given in the question, and if you look at carefully, this cell number 1 and this cell number 2, they are connected in parallel. So if they are connected in parallel, and you see that positive negative terminal, the polarity is also in such a way that it can be added. So E equivalent will come E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2. So 20 by 2, that is the 10 we are getting. 10 by 2, that means 5 we are getting. 1 by 2 plus 1 by 2, 1. So 15 volt. Matlab equivalent EMF of this battery is 15 volt. Equivalent internal resistance, how much it will come? So 1 by 2 plus 1 by 2. So we got it, the R equivalent as 1 ohm. What does it mean? It means this circuit can be replaced by, this given circuit can be replaced by a single battery of EMF 15 volt and internal resistance 1 ohm, and these two battery I have replaced by a single one. So now I don't need to draw it both the battery, है ना? Now I don't need to draw it 20 volt 2 ohm, 10 volt 2 ohm. Both of them I don't need to draw it. Why? Because I found the equivalent EMF and equivalent internal resistance. So that's why I replaced it by what? These two battery I have replaced by a single battery. Okay. And look at the 10 and 50, 10 and 20 ohm. These two are also connected in series only, isn't it? So why I should keep it two of them? Let's keep it one of them, 30 ohm. Understood? Now I want the current. So what is going to be the current now? So now if I want to find out the current, I can find out the current. See that this 30 ohm and 1 ohm. Can I say that this 30 ohm and 1 ohm are connected in series? Please tell me, this 30 ohm and 1 ohm are connected in what? Connected in series. So what is the I will come? So I will come here. This is the I we have. This is the I. This is the I. Okay, so what is the I will come? 15 divided by 30 ohm and 1 ohm connected in series. The 15 by 31 ampere. This is what we have the current. But here we are calculating the current. Just give me one moment. Okay. Okay, so this 15 ohm and 15 by 31 ampere we got it. But this current I got it in the question is what? Is the current through which branch? Tell me. Is this the current I have got through this branch? And not not through 10 volt battery and 20 volt battery. The current I got it here 15 by 31 is this current. But these two branches will have different current, na? And these two branches will have current how much? So that current, if I want to calculate, can I say, this current is something I1 and this current is something I2? Please tell me. Now, I have calculated in the question, isn't it? Current I have calculated in the question. Can I apply a junction law here? Please tell me. Can we apply a junction law here? So if I apply the junction law here, what I will get it? I1 incoming current, I2 incoming current, and should that be equal to the I current? Please tell me. I1 is incoming current, I2 is incoming current, and I is the outgoing current from the junction. So I1 plus I2 should be equal to I. Now I is known to me in the question, but I1 and I2 is not known to me question. So what I will do it? Will I write one more equation? Please tell me. Will I write one more equation? Because we have how many unknown in the question? We have two unknowns in the question. What are the two unknowns? we have the two unknowns I1 and I2. I is the known in the question, है ना? So one more equation. From where I will write one more equation? Can I apply the loop law? Please tell me. What is I1? Is it the I1 in the question? Is it the I1 in the question? And is it the I in the question? Please tell me. Clear? So now I am going to apply the loop law in this question. Okay. So let me draw this circuit one more time, and then I will show you how I am going to apply the loop law. Okay. So if I am going to apply the loop law in the circuit, now please check it. If I am going to apply the loop law, what I will do it. I'm just going to mark these points. Okay. Let me draw the circuit and then I will mark these points for you, so that it will be easy for understanding. Tell me, this 10 and 20, can I replace it by a single one?
Yes, sir.
Please tell me, is it my circuit? My circuit is 20 volt, 2 ohm, 10 and 20 is 30 we have. This is 10 volt, this is 2 ohm, right? What is the current in this branch? I1 current is in this branch. Current in this one, I. Current in this one, I1. Current in this one, I2, right? So one more equation is needed. One equation to already I have I1 plus I2 equal to I. One more equation is needed. I'm going to mark some point. Okay. Let's call this point as A. Okay. Always identify the distinct point what we have. Okay. Matlab, you should mark the point where you will be having the potential difference changing if you go from point 1 to another point. Okay. So let's say this is the point number A. This is the another point B. This is the another point. Let's call it C. C. And this is again what? A. This is the C only. This is the A only. Hai na? Now I am going to write the loop A, B, C, A. Please tell me, loop A, B, C, A. If I go from A to B, which is high potential? A is high potential or B is high potential? Please tell me. Which is high potential, A or B? Is the A is high potential because current is flowing from A to B? So A is high and B is low, and you are going from A to B. So high to low means minus. How much minus? I1 into R. Now I reach the point B. B to C, battery. B to C, there is a battery in between. B is connected to low potential of the battery. C is connected to high potential. Low potential means a negative terminal. High potential means positive terminal. The low to high potential means plus. How much plus? Voltage of the battery. Now I reach the C. C to A minus. Because again the current is flowing from C to A. So C is high potential, A is low potential. So minus. How much minus? I into 30 equal to 0. That is our what? The second equation for us. Okay. Now if we solve this equation 1 and 2, what will happen? We will get the I1 and I2.